I'm going to talk a little bit today about controlling pests with band steam and new cultivator technologies. And the pests we're trying to control are those that we have difficulty controlling with our conventional pesticides. And those are in-row weeds, soil-borne pathogens, which cause Sclerotinia lettuce drop, and also Fusarium wilted lettuce. It's one way to control these pests is with steam. It's a well-known practice. It's been around for at least a century. You raise the soil temperature to a sufficient level of heat, and it will sterilize the soil and control these pests. This technique is still used today, primarily in greenhouses using steam heat. There are also some field machines that come in a variety of different sizes, shapes, and colors. As you can see, they're fairly large, fairly beastly machines, but they all pretty much work on the same principle, and that is, if you look at the picture of the machine in the center, basically they have some sort of a injection spike that is lowered into the ground. Steam is inserted into the soil surface for several minutes. That platform is then raised up, the machine is indexed over to the next plot of ground, and the process is repeated. This process is, as you might imagine, quite slow and energy intensive. So we came up with a concept of using what we're calling band steam. And in band steam, the idea is to treat just a narrow band or strip of soil. In our case with lettuce, something 4 inches wide by 2 inches deep to control Sclerotinia and weeds. That's where most of the sclerotia reside, and also the weed seeds that germinate. And then maybe to a deeper depth, 6 inches to control Fusarium. The advantage of this, of course, is that by treating just a narrow band of soil, we're saving quite a bit of energy, and that should allow us to move at a more reasonable travel speed. Steve Fenimore did some early preliminary work on this concept. He built a prototype single line steam applicator, and it worked fairly well for what it was. It raised the soil temperatures to about 140 degrees for over 10 minutes. And that is important in that, well, I guess what's important is not just the maximum temperature you raise the soil to, but also the dwell time, or how long it stays at that temperature. And for soil-borne pathogens, that time temperature kind of magical number is 140 degrees for 20 minutes. It's a little bit higher for weed seed, 150 degrees for 20 minutes. Here are some of his results. You can see that the use of steam did a really good job of controlling weeds in the seed line, and the numbers bore that out. If you look in the table here, you can see that as compared to the control, it got about 16 times better or improved weed control. It also did a fairly good job on controlling lettuce drop. So we were fortunate enough to receive some funding and improve upon this prototype applicator. I guess that would be the objective, to build a improved version of this, and then to design and test the machine to determine if it was able to meet to raise soil temperatures to sufficient levels to control soil-borne pathogens and weed seed. And again, the temperature dwell time numbers for those two pests are 140 degrees for 20 minutes and 150 degrees for 20 minutes for weeds. The other thing we were interested in looking at was the use of co-applying an exothermic product with the steam. Exothermic compounds are those that release heat. And so the idea with using the exothermic compound, in this case, hydrogen peroxide, is that it would reduce our requirements for steam input to raise the soil temperature and thereby save energy and also allow us to travel at a higher speed. So set up an experiment to determine how well the machine would perform. Looked at 5 different treatments: a steam only treatment, a steam plus hydrogen peroxide injected into the soil, one with hydrogen peroxide sprayed on top of the soil surface, one with hydrogen peroxide injected and sprayed at the same time, and then of course our untreated control. Here's the picture of the our second iteration prototype band steam applicator, basically comprised of a steam generator mounted on a bed shaper. We're injecting steam with some injection knives out in front of the bed shaper. And then we also are delivering steam towards the back of this elongated bed shaper using these funnel or conical shaped devices to apply steam to that 4-inch wide band on top of the soil surface. It takes quite a bit of steam to raise the soil temperature to the sufficient levels that we want. So here's a picture showing that. Again, you can see the pan steamers, and then out towards the back, you can see the steam being output from these pan steaming devices. This is just a picture showing the machine in the field injecting steam. And this is the setup we had for spraying hydrogen peroxide onto the soil surface. Have a short video here of the machine in operation. And in this case, we're traveling about half a mile an hour. And then Nick Barr, who's a graduate student working on this project, is inserting some thermocouples to measure soil temperature. And the depth he has the probe at is about an inch. Takes a little bit for the probe to heat up. But you can see there we're reaching about 160 degrees Fahrenheit in the top inch of the soil.